Hello and welcome to O Institute. Today we are gonna be continuing the chapter Integers of class 7. The earlier parts of the same chapter we covered the introduction of the chapter, properties of addition and subtraction of integers, and additive identity, multiplication of integers. In this part we are gonna be covering properties of multiplication of integers. In the next parts of the in the upcoming videos of the same chapter, we are gonna be covering making multiplication easier, division of integers, and properties of division of integers. Before starting the video, like and subscribe my channel so that you can get the notifications of my upcoming videos. So let's begin. In the earlier parts of the video, we got to know about the closure property and the commutative property. So let's apply closure property under multiplication for integers. Closure property means that in an integer into an integer, it will be equal to a integer. So let's put values to these integers and to prove this out. So let's give this integer the value of 1 and give this integer the value of, let's say, 91. So the answer will be 91, which is an integer. Let's take another example. Let's say 3 into let's say 14. So 3 into 14 is equal to 42, and 42 is an integer. 3 is also an integer and 14 is also an integer. So the answer is so we say that integers are closed under multiplication. Let's do the same for commutative property under multiplication for integers. Commutative property means that a into b is equal to b into a, in which a and b are integers. So let's prove this out. So let's give the value to a, let's say 9, and let's give the value to b as 11. So which would be equal to 11 into 9. So 9 in times 11 is equal to 99, and 11 times 9 is also equal to 99. So 99 is equal to 99. So so now we say that multiplication is commutative for integers. So now we have learned about closure under multiplication and commutativity under multiplication. So now we are gonna be covering multiplication by 0 and multiplicative identity. So multiplication by 0 means that let's take an integer, let's say 13. If we multiply 13 by 0, what is the answer? We have learned in the earlier classes that we have learned tables from 1 to 10. But what if we are multiplying with 0? What if there is no number between 1 to 10 and we are taking a 0? We are taking 0. So the result will be 0. Yes, when we multiply 0 to any number, so let's say 987, we multiply 987 to 0, then the result will also come 0. This is the only this 0 will only be the answer. So now we know when we multiply any number with 0, the result will be 0. So now let's know about the multiplicative identity. Wait a second. Yes, multiplicative identity. We have learned in the earlier video about additive identity. The additive identity stated that when we add something, we have to add something to a number so that we get the answer as the same number which means that the identity of the number doesn't change by adding the number. So, and we learned that the additive identity is 0. Now let's know about multiplicative identity. Let's say we have to multiply 9 to a number, say a, and the result should be 9. So what will be that number? Yes, you are right. When we multiply 9 to 1, the result will be 9. So the multiplicative identity is 1. Let's take another number, say 283. When you multiply 283 to 1, the result will be 283. One multiplying 1 to 283 will not influence the value of 283. So the result is 283. So now we have learned about multiplicative identity and associative and the multiplicative identity and multiplication by 0. So now let's learn about the associativity for multiplication and a new concept of distributive property. So first we need to know associativity for multiplication. We have learned about associativity that if we multiply a into b into c, and we multiply into b into c on the LHS and RHS, but we first multiply a and b, and then in the second on RHS we multiply b and c first, the result will be same. So let's prove this out. Let's say let's put the value of a as 3, b as 4, and c as 1, and we multiply 3 and 4 first, and let's do the same for the RHS. So first we multiply 3 into 4. 3 into 4 is equal to 12 into 1, and 4 into 1 is equal to 4, and we learned about multiplicative identity, so the identity is not changing. 3 4 and 12 into 1 is 12, multiplicative identity, and 3 into 4 is 12. So 12 is equal to 12. So now it is proved that that the product of three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. So now we have learned about the associativity for multiplication. Let's come to the last topic, distributive property. So wait a second. Yes, now distributive property means like we multiply a into b plus c in bracket. If we multiply a into b plus c, the we can also write it as a into b plus a into c. Don't believe? Let's try it out. Let's say we have let's say we give the value to as a 3, and let's give the value to b as 4, and let's give the value to c as a 2. Let's do the same for this one. A 3 into 4 plus 2. So let's do the way a into b plus a into c. This means 3 into 4 plus 3 into 2 is equal to now let's do this as the way 4 plus 2 is equal to 6. 3 into 6, 3 into 4 is equal to 12, and 3 into 2 is equal to 6, and 3 into 6 is equal to 18, and 12 plus 6 is 18, and which is equal to 18. So this means that a plus into b plus c can be also written as a into b plus a into c. In so we can do the reverse also. Let's say we have been given A into B plus A into C. We can write it as A into B plus C. This method can be used in various difficult multiplication problems, like we have given a very large number of numbers and we have to find out the answer by, and there are many arithmetical operations involved in it. So we can use the distributivity of multiplication over addition to do this. So this is known as distributivity of multiplication over addition. So now let's do the same for now let's learn about distributivity of multiplication over subtraction. So let's say distributivity of multiplication over subtraction means that A into B minus C is equal to A into B minus A into C. So A into B minus A into C, and we can do the reverse also. A into B minus A into C is equal to A into B minus C. Let's take one example. Let's say 9 into 7 minus 2 is equal to 9 into 7 minus into 9 into 2. 9 into 7 minus 2, 7 minus 2 is equal to 5. 9 into 5, and 9 into 7 is equal to 40, no sorry, not 63. 9 into 7 is equal to 63 and 9 into 2 is equal to 18. So 63, 9 into 5 is equal to 45, and 63 minus 18 is also equal to 45. This is it, this is minus not plus, sorry for that. Yeah, 63 minus 18. So 45 is equal to 45, hence proved. So we have learned about distributivity of multiplication over addition, distributivity of multiplication over subtraction, associativity for multiplication of integers, multiplicative identity, multiplication by zero, commutativity under multiplication, and closure under multiplication. So in the next part of the video, we are going to be covering making multiplication easier. So that was all for this video. Stay tuned until the next one. Till then, bye.